Okay, we'll get started. Great. Nice to see many of us here. So computer vision is one of the most exciting fields to learn about and work in, and also do programming in. It has a lot of cool applications, as you might have already been familiar with from your own exploration. And I'll be very honest with you. This course is actually probably one of the first courses you're taking in the PMP program, but it's also a course that requires a lot of prerequisites, right? So you might be coming in thinking, oh, well, machine learning, maybe Python, I'm not sure, but we need all of these things for this course. So for that reason, we will discuss some amazing and cool applications in this course, but no promises on getting there because we have to cover the background for it as well. But we'll definitely focus on computer vision and image applications. How far we can get into it is up to how far you can get into the mechanics of it, the algorithms and machine learning and deep learning. So a lot of things are cool, but there's a lot of complex algorithms powering them. So understanding them itself takes a lot of time, right? So for that reason, we're going to kind of balance the kind of applications we'll cover and the kind of background we'll cover in this course, so that you get something reasonable out of the first course in your professional master's program. Yeah. Just put this aside. Okay. So the instruction team, is Fatwir here as well? I'm not sure.
Yes, I'm here.
Oh, you're here. Okay. Okay. Sorry. Fatwir, I was not sure if you're joining, but so there's three folks on the instruction team. There's myself, Karthik, there's Ayush, and we also have Fatwir. Fatwir, maybe we can just, okay. Spotlight you. Okay, so there's Fatwir. So there is
Hi guys.
Ayush, and there is Fatwir. So yeah, okay. So I'll be your instructor. Okay, there is some transcription going on here. Okay, so I'll be your instructor. Ayush is going to be our TA, and we'll also have Fatwir support with the grading. Yeah, so we have a nice team going here for supporting you through the course. All right, so TA and then grader, right? Okay, so like we spoke about, the motivation for computer vision is that a lot of advances have been made in the past decade, especially because of the advent of deep learning. And computer vision, although has been an old area where people have been looking at things for quite some time, understanding images better, understanding videos better, trying to solve problems in that space, doing object detection, image segmentation, and things like that. But more recently, with the advent of deep learning, a lot of things can be done more accurately and in real time because of computational power and advances in deep learning as well. So the combination of accuracy and real-time monitoring of images and videos enables things like self-driving cars or terrain navigation. Or if you have a drone going through an area, the drone is able to spot objects in real time. So all of that is a combination of advance in computing and also advance in computer vision, right? Yeah, so we'll be looking at basic concepts in human and computer vision. We'll understand some building blocks for vision, and we'll also proceed towards machine learning methods for computer vision, right? And hopefully by the end of the course, we'll have looked at some state-of-the-art deep learning methods for different vision problems, image classification, image detection, automated captioning of images, image segmentation, handwriting recognition, and maybe more. But again, there is application of computer vision to these problem spaces. There is also really understanding how they work. So these are two different things. You can take a library and you can apply it to an application and say, oh, I applied it. but that may not mean you actually understood what's actually happening there, right? So in this course, we focus more on the understanding as well, because without the understanding, if you just apply a library somewhere and then you got some result and you're not able to explain why it's happening, then you'll not be able to, make those insights actionable if you were to work at a company, for instance. You'll be asked to explain why this is happening, or if you can change it, and you're like, I'm not sure, I just applied the library. So that's not going to work. So for that reason, we are actually going to also focus on some of the fundamentals of computer vision and understand things better. Yeah, does that sound good? So we'll be having a balance between where you want to go, or I want to go here, versus where we can actually go, because we want to also get there with good intuition and good understanding. Okay. All right. So let's look at some of the cool stuff. So there's a lot of applications of computer vision, as you know. So this is in the field of medical imaging. I taught a course on AI in healthcare in spring quarter this year, and we looked at some applications in healthcare. Medical imaging is one instance. So here you see some MRI images, and then are you able to detect a disease, or are you able to diagnose a disease or a defect based on these images automatically? Or can you support a doctor in making a better decision? So there was a recent article I saw in this space where the article said that recent advances of medical imaging technologies is helping doctors and imaging technology come together so they can do better if they were standalone than if they were standalone. So the combination of a doctor looking at an automated system is better than just the doctor diagnosing the disease or the automated system diagnosing the disease. So there is role for a combination of technology and human in the loop to work together to make better predictions in the case of healthcare, for instance. So that's medical imaging. Also a very complex space because of the different levels of resolution, the zoom, the different technologies keep changing. So and there could be a lot of noise. It's a pretty fascinating yet complex space. So that's one application. Self-driving cars. Anyone, maybe just a show of hands, if you've driven a Tesla or you've got a ride in Tesla. Okay. Or you've driven in a smart car, let's say smart car with autopilot feature. Yeah. Okay, maybe not. Okay, so self-driving cars. If you see, does anyone know how many cameras a Tesla has?
It's like 8, right?
Yeah, roughly around. I think there's 2 on the sides, 1 in the back, and a couple in the front. So probably 6, but I'm not. Maybe 8. Yeah, but I was thinking 6. But that's even 6 is a lot of cameras, right? So there is a lot of data coming in constantly that's getting fed in through these cameras to understand what the surroundings look like for, let's say, Tesla or an automated self-driving car. And it's even despite all of that data, you'll notice that if you've driven a Tesla, it still makes mistakes in low light conditions, for instance. Or, I was once driving on a highway, well, not a freeway, but maybe like a kind of 45 miles per hour speed limit road. And the white line was kind of blurred because there was some sand or something else. So it was not very clear. And Tesla was not sticking to the lane. It was like kind of wandering off when it would usually not do that. So, but as a human, I would not make that mistake. Yeah. So despite all the data that you can feed in real time and use the most, best of the best computer vision technology, you can still make mistakes. So that really helps you understand how amazing our human brain is, right? we don't make such mistakes. We kind of are able to drive in many kinds of conditions. So self-driving cars is a very important application of computer vision. It obviously involves a lot of tech that's kind of put together to finally, get there. So a lot of moving pieces going on, but a key moving piece is computer vision, right? There's also batteries and other things, that come in place, but so computer vision technology plays a key role there. And we also have like standard image classification. So given an image, can you classify it as a particular species of a flower? So we'll actually look at one of, this will be part of probably assignment 2. So we'll kind of look at this data set where you have different subspecies of a given flower, and can you correctly classify it as, let's say, iris setosa or iris versicolor based on their characteristics. So this is a very classic application of computer vision, right? We'll also be looking at that. And I think there are apps these days as well, where you can just, let's say there's an app for understanding a plant. You can just point your camera to a plant and it'll tell you what the plant is. Has anyone used such an app before? Yes, no? Yeah, so feel free to unmute and share, we'll keep it interactive through the lecture. So if you have any thoughts, just feel free to share and then we'll keep discussing it. So yeah, that's another application, image classification, image understanding. Right. Going a little bit more into image understanding, there's like different levels of understanding that can happen with an image, right? You say, okay, do you understand an image? You're like, yeah, I understand the image. So then you say, what do you mean by understanding an image, right? For instance, do you understand this image? You're like, yeah, I understand. There's some sheep and there is a dog. So what is so obvious to us, it's not so obvious to a machine, right? Like you can say there is some sheep. So you already said there's more than one sheep. And you said there is a dog. So you said there's exactly one dog. So you already know, just looking at the image, that there's like, not just some, there's like 3 sheep and there's like 1 dog. So it's so obvious to you. But for a machine, it might just say, I think there's a sheep in this image. Or I think there's a dog, but may not be able to say how many. So that's a level of understanding, but it's not the highest level of understanding, right? So that's image recognition, or you can just say maybe classification. You can also say multi-class classification, multi-label classification. So you can put multiple labels to an image and say, there's a dog, there's a sheep, but don't ask me how many. My algorithm thinks there's a sheep, but I don't know how many. Okay, so that's one level of understanding. Or even more basic level of understanding is, I believe there is more of a sheep than a dog. So that's what this probability shows. This is multi-class probability. So if you think of it as a multi-class problem, you'd say, I think there is multiple classes to pick from, but let me just pick one class. And the dominant class here, based on a probability, would be sheep. But multi-label would be like, you know what? I think there's a sheep, but I think there's also a dog with a high probability. So that's a better modeling, right? Because there's both a sheep and a dog. It's true. But that still doesn't tell you what else is going on in the image. Then comes object detection. You're able to actually put a bounding box around the objects in the image. So you say, oh, there's a dog, there's a sheep, oh, there's another sheep, and there's a third sheep. And you're able to pinpoint the rough location of these objects in the image. So the methods that do that fall under the category of object detection, right? Okay, so that's a better understanding of the image. Now, I'm getting some messages here. Okay, so now not only do I understand the image and I'm able to pinpoint the objects, I'm also able to pinpoint the location of the objects in the image. That's a higher or a better level of understanding, right? Then you say, you know what? Can you just pull out the dog from the image? Just like pull it out. Like I mean, even bounding box is probably not enough. Can you just pull it out? So that is segmentation. You kind of segment that part of that object from the image, kind of pull it out. So you can see, okay, the dog is clearly pulled out. Is the sheep pulled out here? Well, what's the plural of sheep? Plural of sheep is sheep, right? So sheep is pulled out, but then it has multiple in them. So if you want to just pull out one sheep, that's not happening in semantic segmentation. So you need instant segmentation for it. So it's a refinement of segmentation where not only are you able to pull out a specific class of objects, you're able to pull out a particular instance of that particular class. Like if you've done programming, there is a class and then there's an instance of a class, right? They're two different things. Instance is an instantiation of a class. So the same thing here. These three sheep belong to the sheep class. So if you say pull out the class, you just pull out the three sheep. But if you say pull an instance of the sheep, you just pull out one of them. So that is instance segmentation, right? So we'll look into segmentation as well in this class.
So we're now just discussing the general, right? And we'll discuss more in details how we can realize instant segmentation from semantic.
Yeah. We're just covering motivation today. Each of these is like a separate lecture or half a lecture at least to go into how exactly we're going to do this. Yeah. So we'll probably get to this in maybe week 4 or week 5 of this course. There's a lot of ground to cover, but I'm just motivating some applications that we'll be looking at in the coming weeks. Yeah. All right. Yeah, this is another example. So, you go from classifying a single object, let's say a cat, and then when you put a bounding box, you also call it localization. So it's not enough to classify. You want to localize it and say where exactly is it in the image. And then you have multiple objects, so not just a single object. So that's object detection. And then you're able to specifically pinpoint and segment these things. That is instance segmentation. So this is a more, as you go from left to right, you're refining your understanding of an image. And then there's more and more you can say. So when a human looks at an image, you can say so many things that a machine would find mind-boggling. So we understand images so well. Vision is, the vision technology is getting there, but it's not been easy. It's not been an easy ride to understand an image for a machine, right? So let's look at some advanced applications of computer vision. Again, as a motivation, just to be very honest, we may or may not get to some of these advanced applications because the background that's required to even implement any one of these advanced applications is like phenomenal. You need to have a deep understanding of deep learning. You need to know exactly what kind of architecture you're using. You need to be able to know how to train it and, get a good algorithm going, good evaluation metrics. And then when you apply it, it seems to work. So it could be a full project in itself. Each one of these applications could be a full project. Like you could spend like 3-4 weeks just like trying to get it right. But as a motivation, it really is pretty exciting. So let's take a look at it. So, we spoke about understanding images, right? So there's levels of understanding in images. So here's something more, not just pointing to what objects are present in the image, but point to it like humans would do it. How would humans do it? We'd use language, right? You'd say, okay, can you describe this image? You'd be like, I see an elephant. Okay, great. And then I see a man. Okay, I see a football. And then you can start having phrases like, okay, this is the leg of an elephant. So you can have a bounding box. You can just say, what is this? You'd say, oh, that's a leg of an elephant. What is this? So it's almost like a kid looking at a scenery and saying, hey, mom, what's that? What's this? What's that? So even doing this accurately is amazing for a machine, right? Just pointing to different aspects of the image and understanding what's going on there through text. So you want to be able to use a sentence. So that's the next level of complexity or next level of understanding to just saying elephant, just using a single word, because that's like a class. But when you are actually generating text, then we're getting into natural language processing, right? So this is like CV to NLP. So until now, maybe you were just in the domain of computer vision, but as soon as you introduce more than one word that gets generated through a model, that gets into natural language processing. So here, maybe you are combining a computer vision model with a natural language processing model. So you're kind of putting them together and then training them with some examples so you can actually generate these phrases or sentences, right? So yeah, so you can see this is, okay, this is great. You can basically, pinpoint to different parts of the image and you're able to say different things. That's great. But that's still not the same as captioning this image. If you had to just caption it using one sentence, what would you say? You'd say, oh, a man riding an elephant playing with a football in a rural setting, right? Something like that, maybe. Isn't that complex? That seems simple, but it's actually very complex to be able to capture all the different things that are happening in the image and put it into a sentence, right? So that's called image captioning, a much more complex level of understanding of what's going on. So that's image to text. So here, this is, I just found this example on the web where someone built a JavaScript, wrote a JavaScript code so that they can insert an image and it is able to generate text that's generated from Azure Cloud CV service. So it's the image goes to Azure, and then Azure has a library that's able to caption an image and it generates it, and then they put it here. So here, the caption that was generated for this image with this confidence or probability, like you can see probability is not 0.95, elephant that is standing in the grass. Okay, that's a very simple description. But this is image captioning. So you're able to give a caption to an image. And I think there was a recent Kaggle contest on this as well, with Google Images, maybe like a couple of years back. It was pretty popular. It's available on Kaggle. And there's a competition on that. So image captioning, image to text, right? Here's something even more advanced and more recent. It's text to image. So this is a image of a temple. It's really, really amazing. Do you guys know where this is? Anyone know where this temple is located? Just take a guess.
Somewhere in India.
Somewhere in India, right?
Yeah.
Supposed to be, but this temple doesn't exist. It's generated by AI. It's completely generated by AI. There's no such temple. So this is generated through a web interface called Midjourney. You can look it up. The link is provided in the PDF. So the person who generated this image through the AI, which uses computer vision, is basically type something like ancient India with ornate temples, waterfalls, and fireflies. So they gave some different keywords, and that was the input. And there is a base set of images, you can say a very vast library of images that this AI depends on in generating photorealistic or artistic images that look really real. Of course, it looks like a fantasy, right? There you can see there's like some kind of a fantasy going on here, but it does also look real, right? It's like, but it's completely generated by an AI. So this is not real. So this is a very recent development, which is you reverse it. So okay, image to text is complex enough, but text to image, that's crazy, right? But it's happening. And I think we'll have this as part of assignment 1, is just go generate an image of your choice using your favorite text. And maybe we'll post it on in your assignment, but also on Discord, where hopefully, is everyone on Discord? Yeah, you must have got an email with invitation for Discord. So do join Discord. All our communication going forward will be in Discord. Yeah. So yeah, part of your assignment 1 will be to just generate an image of your choice. It could be anything crazy, but post it on Discord, and hopefully you get excited about it. Yeah. This is another example. Again, it's not real. There is no such image. Maybe it could be real. It'll be great if it was real, but this is again generated by an AI. Right? So really fascinating. There's also a research paper that I've linked here. You can take a look on how they do these text-to-image models. Pretty complicated, but again, it's like a lot of like building blocks. You start with the alphabet A, B, C, D, and then you say, let's create words, and then you take words, you create sentences, and then you take sentences, create paragraphs, and then you take paragraphs, create a document. So if you say, how did you create a document? You have to go all the way to the alphabet. So the same thing here. How do you generate an image from text? Well, there's a lot of building blocks, but those building blocks are present. It just has to be put together in the right way, and you're able to get here. I think I'm getting some messages here. Once again, let's see if my Discord is open. Okay. All right, I'm gonna close it. Okay. All right. So yeah, feel free to generate your favorite kind of image using Midjourney, and that'll be part of your first assignment, just as a way to understand the capabilities of computer vision. You can just take a look at it for yourself. Whether we'll get to really understanding how it is done in this course, we'll see, because we have to cover a lot of material before that. But it could be like something that you can aspire to understand at some point on how it's exactly done. Yeah. Building on top of this, okay, there's one more. Okay, anyone know what this is?
Salamander? No?
Salamander? Yeah. Who said that? Sanjar?
Yeah, me.
Yeah. So this is actually based on a salamander, although it's not real. Again, this kind of this type of shape and everything is not real, but it's based on a salamander that's actually real. So let's look at what the real one is. This is the real one. This is AI. So the right one is actually real, but the left one is based off that, and it's not real. So you might see something like this in like a Pixar movie or a Disney movie or something, right? The one on the left. But the one on the right is real. It's a type of a salamander that refused to grow up. So it has all these, amphibian kind of goes through different stages. It kind of refused to grow up. So it still has all these other things sticking out. So it's called axolotl. So this salamander is called axolotl. So someone actually generated this in Midjourney based on axolotl images and kind of added some different kinds of color and everything. So that's what you see here. So text to image. Okay, next level, which is very, very recent. I think I just saw a posting on this a couple of days back. Text to video. Take a text piece of sentence and then generate a whole video, or maybe generate TikTok style video, right? Let's see if we can, let me see if I can, I'm just gonna, yeah, maybe it'll be worth playing some of this. pause the video here. Okay, great. All right, so this is called Make a Video. It's a state-of-the-art AI system that generates videos from text. So there's a paper on this. You can take a look at it here. Of course, it's not like super realistic, but this, for example, a dog wearing a superhero outfit with red cape flying through the sky. So you type this text and then you get a video that looks like this, completely generated without any, any other inputs. Here's another example: a teddy bear painting a portrait. This is other examples: a cat watching TV with a remote in hand. So things that you could probably never see in real life, but you could imagine happening, is something that you can generate through this. But obviously there's some like low resolution going on here, some warping of stuff, but it's like a start. So feel free to explore this as well. Put a link in the slides. The slides, by the way, I've shared on email, but once the website is in a good place, we'll also put it on the website. So you can access the slides for the lecture before the lecture starts. Okay. All right. So that's text to video. And there's a research paper on it. Feel free to take a look at it. Yeah. All right. So, so some computer vision spaces will actually get to touch on in this lecture. So that was motivation, right? So we may not be covering text to video. We may not get to text to image as well, just because of the complexity of the models. So when I mean get to, it means like actually implementing the model and understanding it, right? Because that could be a project in itself. But feel free to explore it on your own. Like these are all available, papers are all available. You can just take a look. But what we will actually look at is some building blocks, like that alphabets and words and sentences. We'll get to maybe sentences. We may not get to a paragraph in this course, but we'll have the building blocks in place in the course. So some of the things that you might know from the past: image denoising, image smoothing, basic things, convolutions, refresher of what you might have looked at before. Image classification might be new to some people based on your background in machine learning. Object detection, semantic segmentation, maybe instant segmentation, image embeddings. This is a big one. So there's like fairly complicated models coming out these days, which can do universal encoding of images or image encodings or embeddings that are useful in many, many situations. You can do different kinds of tasks once you have these embeddings. So what are embeddings and how are they useful? So we'll look at that in this lecture. And then I think image to text is something we'll get to. So image to text and image captioning we'll get to. So we'll look at a model that actually you can take an image and then say, give me a caption for it. Describe the image to me, right? So we can get to that. Text to image we'll cover at a high level. We'll look at the model architecture at a high level, but we may not have time to actually implement it in the short duration of this course. Text to video, feel free to play around with that demo and read the paper on your own. Yeah. Does that sound good? Yes. Okay. We also have the survey. Let me again go through the results of the survey and see what's come up. I'm going to pause the video again, recording. Okay, so here's a summary of the survey results. We have like 23 responses. Okay, what aspects of this course would you like more emphasis on? A lot of people for applications, algorithms, programming, and intuition. So all of these are interlinked, right? If you just did programming, great, but you may not have the intuition. If you just focus on intuition, but you didn't do programming, then you might not get the implementation level understanding of how you actually do it. Algorithms, again, if you did programming and you had the intuition, but you didn't understand the algorithms, then you may not be able to tweak things or explain things in an interview or to yourself also what's happening. So understanding of algorithms is also important. But yeah, we will be focusing a lot on applications like we looked at. Keep the application in mind and then work on the models or algorithms that are needed, the programming pieces that are needed to go through those applications, right? Do you have prior experience in machine learning? So 50% is no, 40% is yes, or 45% is yes. This is okay. To be honest, I was thinking that people will have a background in machine learning because computer vision is an advanced course. But I also understand that this is probably the first course that many people are taking in this program, right? Is that true for people? Probably the first course you're taking, first quarter. Yeah. So given that is true, and I think it was offered last year as well as the first, in the autumn quarter, we will cover the necessary background in machine learning. However, if you think you're lagging behind somewhere, I'll point you to some resources so that you can catch up on machine learning as well, as much as is needed. But we'll cover enough machine learning for computer vision, and we might go through it quickly, given all the things that we want to go through in this course. Yeah. So a combination of some things we'll cover in the lecture, plus your own, reading on your own will help you get through the machine learning piece for this course. But also, I think next quarter, I'm teaching a course, Advanced Introduction to Machine Learning. So you're welcome to take that course as well to go in depth into many applications in machine learning beyond vision as well. So it's widely applicable. Also, many methods, many algorithms get covered in that course, a really broad spectrum of things. So if you want to solidify your understanding of machine learning, I would point you to that course. Great. So that's that. Do you have prior experience with image processing or vision? No, yes. MATLAB, edge detection, heart rate detection. Okay, great. Human activity recognition. Okay. OpenMV, AI in healthcare. Yeah, okay. It helps to have some background in image processing. If not, the first two assignments of this course, we are going to kind of brush up our background on image processing. So some denoising, some smoothing, some transformations on images, some basic things that should be part of your understanding and toolkit for working with images we'll cover in the first two assignments. So as you work on that, if you didn't have the background, you'll catch up. If you had the background, you'll just refresh it, right? So yeah, this is something I want to mention. In this class, we will be catering to the average. So if you are, lower on the understanding side, or you're catching up on many things, you may have to work harder. But if you already used PyTorch and TensorFlow and you've done a lot of computer vision applications, you might find a little bit slow on the progress that we're making in this course. So we will be taking a balanced approach. For that reason, you may find it slower or faster, the pace at which we're going, right? But if in any case you're finding it slower or faster, just reach out to me and we'll have ways to deal with that. So if you're going fast, if you're going slower, then I'll give you additional things to work on your own, so you can augment your understanding. If you think it's going too fast, then we should also discuss that, so that you feel comfortable going forward with deep learning that will be coming up and all the other assignments that will be coming up. Yeah, I mean, but it's a great. I would say this course is an amazing course to get started with machine learning in general, but it'll also involve a lot of work. So you will learn a lot through programming and programming assignments, which also means you'll have to spend enough time for it. But if you did that, you will get the most out of this course, right? So, but it's a great thing. I mean, computer vision is really exciting field. There's, as you saw, there was like some recent amazing innovation that just happened this week. So these kind of things keep happening. So it's a great field to be in. So I think the hard work that you put in to this course will definitely give you benefits going forward. And anything that you think, oh, I still don't understand backpropagation. Okay, that's where we have the next course on machine learning. So because we might just brush through backpropagation, we might just brush through neural networks, so we can get to the topics that applications that we want to go to. So wherever you think there is missing gaps or you want to have a deeper understanding, feel free to take the next course or do your own learning, right? And there's so many resources available. Yeah, I think that's what I want to share here. Okay. How is your background and familiarity with linear and matrix algebra? So we're okay with it. Yeah, I think we'll be covering some of this in the first two assignments as well. So some mathematical background that's required for processing images. So you'll kind of go through it, and also programming background. So you need to be able to program and code these things. And the primary language for coding we'll be using is Python in this course. And you're encouraged to use the Google Colab as a way to submit assignments. And we'll also probably share template for programming in Google Colab. So you can get started with some starter code in Google Colab and then fill in the missing pieces and then make your submission, right? So most of the assignments are going to be programming. So if you've been using MATLAB or something else, you may have to switch to Python. MATLAB is great for prototyping, but not good for an industry context. So if you've been using MATLAB, it's a good time to learn Python and switch to Python. Okay. All right. What topics in computer vision are you excited to learn more about? Algorithms, visual recognition, pose estimation. Yeah, so these are some advanced topics. We'll see. We may or may not get to it. Yeah, help process images. Yeah, for sure. We'll be doing that. Object detection, yes. Video recommendations. That's a good one. Yeah, there's a lot of industry applications to video recommendations. For instance, Insta Reel recommendations or TikTok recommendations. So if you were to interview for one of these companies, this is a good topic. YouTube recommendations. I think we had a separate course on recommender systems in summer. So again, you can spend a whole summer, you can spend a whole 2 months on just recommendations. So maybe I'll just keep this in mind. Maybe we'll touch on this in one of the lectures as an application at a high level. So we can always touch things on a high level, like at a system design level or a machine learning design level. We can always go through things. But as you know, a lot of learning happens in the details as well. So we may not be able to go into details of recommendations, but I think that's a good call out. We'll probably touch on this in one of the lectures. Image captioning, yeah, image to text. We spoke about that. Self-driving and driving assistance. Again, maybe at a design level, we'll probably go through this, and then you can imagine how the pieces will fit together. So we might go at that level. Human vision, CV transforms, yeah. Metric monitoring and object detection, GANs. Yeah, industry. Yeah, so we will be keeping things relevant to the industry setting because it's a professional master's program. So we will talk about scalability, we will talk about latency, we'll talk about trade-offs that are very practical in an industry setting, right? So we'll definitely do that. But yeah, will we have time to talk about GANs? I don't know. There's a lot going on in the vision literature. So, and we only have 2.5 months. Interested in learning machine learning. Yeah, we'll do a crash course on machine learning in this course. Great. Object detection, classification. Yeah. Yeah. Relation to real life application. Okay. I think we've covered it. Yeah. This is great. Have you used PyTorch before? No. Yeah. So we'll be using PyTorch for when we get to our neural networks, backpropagation, deep learning module, and looking at some of the, let's say you want to do image to text. Okay, that's a complete deep learning model. You're going to have the computer vision on one side with all the CNNs getting stacked, and then you're going to have the NLP modules, maybe with LSTMs or something else. And then PyTorch is going to help you put those things together. So we'll have a few assignments on PyTorch towards the end of this course. So you get exposed to PyTorch, and again, it'll be a learning curve. So you will have to, you may find yourself putting in extra time to even get things going. So, but it's totally worth it, right? Yeah. Okay, this is great, 100%. Okay, what's your go-to thing to de-stress? Working out, running in the park, rock climbing, watching TV series, meditation, video games, listening to music. Yeah, sleep. Yeah, sleep is so important. You know, we don't usually talk about these things much in a class because it's like your personal thing, right? But I like to talk about it because it impacts your learning. If you didn't sleep, what are you going to learn in the class? If you didn't take care of your stress, what are you going to learn in the class? It's just going to go over your head, or you might be nodding your head, but it's not registering. So these things happen when we're sleep deprived or when we are stressed out, right? So it's good to at least know how you, yeah, this is great. Seattle's a great place to do a lot of outdoor stuff. So nice to see some of these hiking, rock climbing, all of that. Great. Awesome. Cooking. Yeah. Pandemic has taught us how to cook. If you didn't know already how to cook, you were forced to start cooking, right? Great. Awesome. Play badminton. Okay. Yeah. I also wanted to mention that I kind of have a second, I could say part-time hobby that I do over the weekends is I teach seminars on stress management. And I find this to be incredibly helpful for myself, but also many of my students have taken some of these seminars in the past and have benefited themselves, like even to the extent of helping them land a job because they were not so stressed in their interview or interview prep. So all these things are really real, like interview anxiety, you know, getting that call, you know, making sure you land a job, all the stress of that, all of that is really real. You cannot brush it aside. So if there are tools that can help you smoothen your experience, why not? So that's what these seminars are about. I might share, especially those who have shared, you would be interested in learning about it. I'll probably share some resources or seminars coming up that I'll be hosting outside of class time, right? But definitely going to help you in class time as well. Okay. All right. Any thoughts on the seminar, survey we went through just now? Okay, great. It's good to align on expectations. So I think this survey was useful for me for sure, because now I understand, you know, where people are with respect to the class, what's going on. Okay, yeah, that makes sense. Okay, great. So let's go to some more logistics and high-level understanding of the breakdown of the course and things like that. So in terms of breakdown of the course, there is obviously, you know, applications and what's computer vision. So we spoke about some of that at a very high level today, but we'll be going into each of them a little bit more in the coming weeks, right? There's machine learning models. So this is like the fundamental building block for almost anything that's, you know, happening in the industry these days is machine learning models. You can say, you know, deep learning is a subset of machine learning, like more sophisticated methods that have much better performance. So we'll start with machine learning models, and then we'll jump to deep learning maybe in week 5 or week 6 of this course, right? So once you've covered enough background on applications, enough background on machine learning, you've done enough, got hands-on with some of the programming assignments, you feel more comfortable, then we'll get started with PyTorch and deep learning. And then again, explore more of these applications. Computer vision problems, yeah. So there's distinct problems in computer vision: object detection, instance segmentation, image to text, text to image. So we'll be looking at some of them in this course. There's a lot of classic computer vision that people usually cover in a computer vision course. So I am kind of choosing to skip it in favor of things that will actually be used in the industry. Does that sound good for people? So you might want to understand color better. We may not be discussing that so much in this course, but it might be part of a classic academic computer vision course, right? Because if you take time for that, then you will have less time for all the cool applications that you may want to look at, as part of this course. So we'll skip some topics in favor of other topics that are more interesting and useful, that we believe is more useful for us. Yeah. Okay, and then business context. Yeah, so this is very important. Anytime you look at anything, like I want to do classification. Okay, I went to scikit-learn. I, picked my favorite classification library, classification module, and then I applied it to my data set and I got results. Yay, I'm done. I understand classification. Then you join a machine learning team, and then you realize, oh my gosh, there is so much more to just classification. There's this whole data pipeline, there's this whole machine learning pipeline, there's this issue of scalability, and scikit-learn is probably going to fail at that point. And you're like, oh my God, I need to do something about this, something about that. So all of that is business context. Understanding how things happen in a real business when you implement these things. Business context also refers to what applications does a business really care about? Like in computer vision, how does computer vision apply in Amazon, for instance? Have you thought about it? People do use computer vision in Amazon. Where do they use it? And yeah, maybe this is a good thing to ask right now. Feel free to share.
Maybe in object sorting using industrial robotics manipulator, I mean.
Yes. Have you guys seen one of those videos that automated sorting using a robot? Yeah. Yep, absolutely. So different things are going on a conveyor belt, and then you want to put the objects in the right bin so that they get sorted, and then you can But for that, you need to be really quick. So it combines robotics and vision, because the robotics is taking care of the mechanical moving pieces, and the vision is telling the robot what to do. Okay, this is an object, you need to do this. All right, great. Any other example? Visual advertisements. Yeah, I mean, there's many interesting examples. Like, for instance, you have an image of a product, and for some reason, the image is not matching up with the text description. Some seller decided to put up some product on Amazon. They're like, these words are really cool. They get a lot of attention. Let me put it up. And then, but it's not matching up with the image. Or the text is right, but the image is something else. It's like, it's grabbing your attention, but it's not really connected to the product. So these could be confusing customers. If that's the case, you want to know if they are confusing or not. So what part of computer vision would you apply? Like what kind of a model would you apply there? Anyone?
Maybe also an example of Prime Air, drone that delivers goods, and that drone use computer vision to navigate through the infrastructure.
Yep. That's definitely there. Yeah, Prime Air is all vision. Yep. In the context of spurious image, or spurious product descriptions, you can do image captioning, right? You caption an image and see if that caption matches up with the description or the keywords there match up. If they don't match up, then that's a spurious kind of hodgepodge of text and image that the seller decided to put up on Amazon. So that's an example. So there's many such applications that you can have. Also, I think what's it called where you actually walk into a store and you don't have to pay, and then forgot the name. You just pick whatever you want from the store, and then you just Amazon Go. Yeah, great. So Amazon Go is again an example of vision, right? There's many things going on there, but one of them is vision. Okay. So it's useful to think in terms of the business context as well. So if you want to land a job in computer vision, just think about what companies out there might be using what kind of models for what kind of applications. So helping you think along these lines will help you in your interviews as well at some point when you want to start interviewing. And if you think you want to go down the route of computer vision, all of these, I mean, not just for this course, any course that you're taking in the machine learning, deep learning specialization, take any method and say, which company would I use this method for and for what application? So that will keep things real for you. So you will see that, okay, what are you learning here is actually something you're going to apply somewhere, someplace. And that's also a skill set to be able to model a business problem as a machine learning or a computer vision problem. That's also a skill set that takes time. Sorry, Yubo, you were saying something? Okay. Okay, great. So that's a breakdown of the course. Right. So in terms of week by week syllabus, so we have about, I think, 10 or 11 weeks. So okay, this is kind of the rough breakdown of what we'll be looking at with each week. So this week, of course, is short, but motivation applications of computer vision. And we'll be looking at some image processing background in week 2, transforms, convolutions, feature extraction. And then we'll be going into machine learning for computer vision. So some of the classic topics in machine learning that are pertinent for computer vision, like image classification, for instance, or feature engineering for image classification. How do you use SIFT features? Things like that we'll cover in machine learning for computer vision. How do you do clustering of images? How do you identify digits in images? How do you classify, different kinds of problem spaces? So that'll be week 3 and 4. Week 5, now that we have covered basics of machine learning and some basics of computer vision, and we will jump into neural networks and convolutional neural networks. So CNN is going to be kind of the bread and butter of some of the advanced computer vision methods that we'll be looking at in this course, but also in general. CNN is like a staple diet. You'll see CNN show up in almost every advanced computer vision model, like including image to text or text to image. There's a CNN happening somewhere. Then we'll be looking at, obviously, you need to know how to implement neural networks. So that's where PyTorch comes in. So we'll have a PyTorch tutorial. We'll cover some of it in class, but also I think our TA Ayush will also cover it in the office hours or the quiz section. So you'll also get more exposure to that there. And then we'll move into object detection, instance segmentation, or semantic segmentation. And then we'll look into some more of the deep learning application CV, especially image to text and text to image. Yeah, if we have more time, we'll be so again, this piece is a little bit flexible and fluid, depends on how we are progressing through the quarter. So we have a little bit of flexibility here to advance to the topics based on where we stand. But if we have time, we'll look into more deep learning applications and computer vision as well. Yeah. Okay, so that's a rough breakdown. And obviously, along the way, we'll be covering a lot of algorithms, and we'll be going into some of the math as well. So the assignments will actually give you a lot of the details into any one of these topics. So doing the assignments is the key to learning, right? Lecture is probably, I would say, 30%. But you need 30% so that you can get the 70% in your assignment, right? That's the way I think about it. Okay, so some prerequisites for this course, which if you are missing or you need to refresh, that's okay. I believe most of you should be fine, but if you think it's overwhelming, feel free to reach out. So some basic machine learning and image processing, some combination of this. Maybe you have background in image processing, that's great. That'll be good. Or if you have some basic background in machine learning, that's also good. If you don't have background in either of them, you may have to catch up quickly in the first 2 weeks, right? Same thing with Python. If you haven't been exposed to Python at all, then I would start right away, like start learning Python right away, because that's going to be our staple diet in this course. Some background in deep learning is going to be helpful, but not required. So this is helpful. Linear algebra, yeah, I think in the context of, I'm hoping most of us are good with matrices and matrix algebra, but if not, again, you may have to catch up on that. So yeah, this is kind of like the breakdown on prerequisites. But if any of these areas like stand out or is something that you need to catch up on, I would do that in the first 3 weeks, except for deep learning. So deep learning we will cover a little bit later, but the other 3, if you think, oh, really Python? Okay, I'm not sure, then I would start right away so that you can actually have a good time in this course. Okay. So just a heads up, plugin for next quarter. So this is what I taught last or this year, or the previous academic year, which was winter 2022. I taught this course, and this was a breakdown. We looked at kind of a lot of breadth in machine learning. So linear regression, classification, clustering, anomaly detection, data visualization, deep learning and NLP, deep learning and vision, deep learning in general, and a lot of Kaggle contests across different applications. So people found it really fun to go through the assignments and understand machine learning better. So and this is coming up next quarter. So you might, I mean, if you're interested, you might as well take this next quarter. Okay. Okay, let's get to assessments breakdown. So I've not done this before, but I want to give 5% to keeping your Zoom video on, because I've requested people to keep their Zoom video on in the previous courses, and people weren't taking it so seriously. So I'm just going to put it here. How are we going to monitor it? I don't know, but someone will be monitoring it. Maybe Ayush or Fatweer will be monitoring it and adding it to your grade. But it's a very easy 5%. Just turn your video on and you're good to go, right? So don't ask me if you have a few lectures where your video is off, few lectures where your video is on, what's the percentage? I'm not going to answer that question, but just keep your videos on and you'll have a good time. We'll also have a conceptual assignment just to cover some concepts in computer vision. May not be as frequent as a programming assignment, but we'll have one every 2 or 3 weeks so that your concepts are also clear. So we'll have some interesting questions in there, maybe 2-3 questions that you can just ponder on and answer. So that'll be conceptual assignment, 10%. Bulk of your grade is going to be, oh, this is not adding up to 100. So there's something missing. Okay, we'll come back on this. It's adding up to 90. There's something missing here. Okay. What is missing? Oh, I see. Yeah, there is in-class exercise. That's what's missing. So we'll have some in-class exercise as well. So in the Zoom session or in class on Tuesday, there'll be some in-class exercise where you can just like, you have a question, you'll have a couple of minutes to answer it. just go through it and answer it and then record it on a poll. And then that'll get about 10% of your grade, right? This is 10%. And then we have programming assignments. This is going to be bulk of your grade, 45%. And this is where you're going to learn the most. Just, running through all of that, running through that PyTorch assignment, running through that, convolution assignment, running through your deep learning assignment. That's where you're going to learn the most. So we have the bulk of the grade there. And these two are connected. So we're going to have some mini projects and we're going to have some assignments. So mini project is basically more of like a 2-week project. So programming assignment is 1 week. So that's the only difference you can say. But also with a mini project, there is more level of complexity and more level of detail that you will go through in the mini project, right? Maybe for instance, image to text might be a mini project. So we'll put a Kaggle contest on image to text, and then you'll work on your computer vision model, you'll work on your NLP model, you'll piece it together. That all of those moving pieces are going to take some time. And then obviously we'll have a Kaggle contest. You want to see how you're performing. And it's fun. Kaggle contests are something we've done in the past. How many of us have done a Kaggle contest before in some previous course, or show of hands? No. 1, 2, 3. Okay. Yeah, if not, you'll get exposure to Kaggle contests in this course. It's really fun. It's more than an assignment because you have your team score, but you also see other people and how they're doing. And it's a friendly competition to do better on some metric. But it's also a motivation to understand material better. So people really get hooked onto the Kaggle contest because they want to get to the top of the leaderboard. But it's a more of like a motivation to learn better. So I would focus on the learning, and then you'll obviously do well. So yeah, so we'll have mini projects as well, maybe a couple of mini projects. Rest are programming assignments, and then we'll have a couple of conceptuals, and in-class exercise will happen every lecture. Right. Okay. Any questions on this? Okay, all good. All right, so that's kind of like logistics and setup. Maybe you'll take a 5-minute break. I think I've found this in the past as well, that I sometimes ask, do you need break? And people say no. And then after half hour, they're like really tired or distracted. I'm like, oh, what's happening? So then I realized, okay, we didn't take a break. So let's take a 5-minute break and then we'll come back and then we'll maybe go for another 20 minutes today. Yeah. All right. Let's get started. So machine learning is fundamental to computer vision, right? So we'll just, I think today we'll just kind of touch upon these connections and go a little bit on a conceptual understanding of machine learning. Something I find people have found useful in the past courses I've taught as well is to kind of understand machine learning on a more high level before we dive into the details of it. So ML and CV, you can take computer vision out of machine learning, but you cannot take machine learning out of computer vision. So what does that tell you? It tells you that machine learning is foundational for computer vision, but it's much more broader. There's many more things happening and many more applications of machine learning. But one of the fundamental applications of machine learning is in computer vision, right? So what is machine learning? It's a lot of things. It's unsupervised learning, it's supervised learning, it's classification, it's regression, it's dimension reduction, it's clustering, it's so many things. So that's why we have a whole course in winter 2023 on exactly this. But if I were to give you some definitions of machine learning and ask you which of these are right, what would you answer? Just take a look at this.
Maybe third one.
Sorry,
Maybe third one.
third one. Okay.
Yeah.
Maybe all of them.
Maybe all of them, you know.
Yeah.
Okay. Okay, any more answers?
I'll go with second one.
Third and fourth one.
Third and fourth one.
Yeah.
Second one. Okay, great. Yeah. So, yeah, there are multiple answers to this. Machine learning is code that improves itself with data over and over time. Yeah, in general, it's true, but there can be exceptions. So all these statements come with some exceptions. It's not true that more the data, the better the machine learning model. More the data, better the machine learning model to some extent, to the extent where it's useful, but after a while, it may not be useful. So you may not improve. Over time, again, depends. So a lot of, okay, that's, so, but the first statement is true. Machine learning is a software that is smart. You can say in that way. A lot of software is like designed to do something specific, and then it executes it, and that's it. But machine learning can improve itself with more data. So that's true in general, but there are exceptions. Machine learning is helping machines learn to be smarter. Yeah, that's true. Machine learning relies on big data. More the data, the better the performance. Again, this is connected to one. You cannot, yeah. It's a little bit of an ambiguous statement. It is true in some cases. It is not true in some cases. More the data, the better the performance. Yeah. So we have to be a little bit careful with this. If we use this principle and then you're working at a company and you say more the data, I don't have enough data. I need more data, more data, more. The person, your manager is going to be like, I think you're not doing a good job. I've already given you enough data. Tell me why you need more data. They're going to ask you back, why do you need more data? Can you please tell me? And then I will give you more data or get more data yourself. So you need to be able to justify why is more data better for your machine learning problem. So having that understanding is important, right? Let's see, if you were to graph it, so this is learning, and then this is maybe the data axis. There might be some flattening that happens. So yeah, if you're in this regime, more data is better, right? But if you're in this regime, you may not learn from more data. So what that tells you is you need sufficient data. Whether you need more data or not, you need sufficient data to be able to build a good machine learning model. And what is sufficient varies from problem to problem. For certain problems, simpler ones like spam classification, or you have image classification, or simple classification problems, like you need sufficient data and that's good enough. But for things like you want to do text to image, or image to text, or one of these complicated computer vision problems, there's usually not enough data. So that's where you would say more data is better, because you're not hit that sufficient mark. You don't have enough examples. So more examples are usually better in that scenario. So we cannot really put a blanket statement, but understanding the context of which problem space you're dealing with can help you make these statements more accurate, right? Great. Machine learning makes lives of humans easier. Yeah. So most of what we do in machine learning is not meant to complicate lives. If it is complicating lives, then yeah, find a better application for machine learning. But it can make lives easier, right? So that is for sure. Okay, what is machine learning? So I want to give you a high level perspective on this, and I found this to be very instructive for in previous classes as well. So have you noticed how a kid learns? So you show a kid, let's say a 3-year-old kid, and you say, can you tell me what this is? And the kid is like, I don't know. And you say, this is an apple. Okay. So the kid is like, okay, this is an apple. I got it. And then you say, what is this? What do you think the kid is going to say?
I don't know.
It's going to say, oh, that's an apple because it's red. Right? If that's what the kid got from the apple, is that its apples are red. So apples are red, so this is red, so this is an apple. Right? Very basic logic. Then you say, no, that's not an apple. That's red, but it's a cube. Okay. Because it's not round. Apples are round. Okay. So then the kid is like, oh, if something is round and it's red, that's an apple. Yeah, that's fair, right? Then you say, what is this? You're like, that's easy. That's an apple. Say, oh, wait, but why do you say it's an apple? Well, it's round and it's red. That's what you said. So you say, no, it's round. Yeah, but it's not exactly like perfectly round. It has to have a stem and it has to have this kind of a shape. Then it's an apple. You say, oh, okay. So let's go back here and then maybe understand that there is some kind of a shape going on there. And that's an apple. Okay. Then you say, what is this? And the kid is like, no, that's not an apple. Why? Why would the kid say it's not an apple?
Because it's not red.
Because it's not red. You told me apples are red and they have a certain shape and it's kind of round. Now you're showing me something that's green. Obviously, it's not an apple. Then you say, well, apples can be green too. Then it's like, kid is like, oh, I think I learned something new today. And then you show this. So is this an apple? The kid is like, yeah, that's a blue apple. You say, no, there is no blue apple. That's imaginary. There's no such thing as a blue apple. Now the kid is confused. So this is how machine learning sometimes is. The more features you expose, the better your understanding of what something is. Or you could also say your understanding shifts. This is an example of more data is better. Because if you just give me one example and say this is an apple, I might just pick up on the color and say, oh, red color objects are apple, because you just gave me one example. But then you gave me 2, then I picked up something else. You gave me 3, I picked up something else. Then you gave me 4, I picked up something better. So maybe after 4 or 5 examples, I am now after 5 or 6 examples, the kid is, hopefully good with apples, right? So this is how the human brain learns with examples, but good examples. You should give enough good examples that you can actually learn. So good examples are able to explore different features. So if you look at the features here, we have color, we have shape. Anything else? Yeah, color is easy, but shape is complicated. Texture, yeah, John, right? Texture is also complicated, but even shape is complicated because you have to, like, what's the shape of this? If someone says it's round, well, this is round too. Then you're like, oh, no. So size, yeah, size also. What if you have a smaller sized apple, right? They say it's not an apple. So again, it's luster, yeah. So many, now we're able to say something more, describe things a little bit better. But you can describe all of this and still not be able to pinpoint an apple if you have not seen it before, right? It's like describing an elephant. It's like, oh, it's long, it's wide. Oh, is it a house? No, it's not a house, it's an elephant. It's black. They're like, oh, what is it? So sometimes it's hard to just describe the features and understand exactly what the object is. So that's what a machine is trying to do, is you're just giving these features and telling it, hey, figure out that this is an apple or not. So this is a very, very simple example, but very powerful in understanding how exactly we learn as humans, and therefore how a machine could learn better with more data, right? So machine learning is understanding patterns in data, right? So like we said here, there is some texture, there's some, I think someone said shine, or what is that? Luster, yeah. There's a luster to the apple. So you look for the luster. These days people put some wax on the apple so it shines a little bit more. So luster, it looks more attractive. But yeah, so you're looking for certain patterns in the data to understand what the object is or what you're trying to do, right? And understanding patterns is learning, right? What is learning? Learning is basically understanding patterns. Anything, take any problem, computer vision, image segmentation. Okay, there is a pattern. There is a pattern of a sheep that looks like this. And I'm trying to fit it in the image. And then if I fit it, then I say it's a sheep. So again, it might be a complex pattern, but it's still a pattern. So understanding patterns in data is machine learning, right? And it's also knowing what combinations of features or factors in the data contribute to a decision. So sometimes you have a lot of data, but you don't know which pieces of the data are actually contributing to your decision making, right? For example, an apple actually has a lot of data. Did you realize that? Just a simple apple has so much data, so many features, right? So understanding which features actually contribute to a decision making. This is what we call feature engineering, is building features in a way that's actually useful to make predictions. And in companies, people actually have a whole data engineering pipeline around this to build feature stores. So people say, oh, I came up with a new feature for images, and I'm going to upload it to my feature store or to the feature store. Any team that wants to use this feature, feel free to download it and use it in your model. So feature stores are like now pretty ubiquitous in many companies as a way of democratizing features that people have worked hard to identify, but might be useful for other tasks and other teams, right? So machine learning helps you, yeah, this is more of a philosophical thing. It helps you appreciate human learning. We take our own learning for granted. Like you take a kid for granted. You're like, you couldn't even recognize an apple, but you didn't realize how complicated of a task identifying an apple is, right? You're like, oh, that's a kid's thing, can't even identify an apple. But our brains are so sophisticated and smart that we think identifying an apple is not a big deal, but a machine can have a difficult time. Like even now, you apply some of the deep learning methods, and it could say an apple is something else if it has a different tint or a different lighting. You change the lighting, you change the size, whatever, and then it would say now it's an orange. But it was working fine before. So yeah. And let's say driving, you take driving for granted. You're like, oh yeah, you just get a driver's license, you can drive. But a simple act of driving requires tons of intelligence. And yeah, like we know, some electric cars still make mistakes despite a lot of data. So there is some gap between human learning and machine learning that is still not filled, right? Like especially with daily tasks. With daily tasks, we are really good. We don't make mistakes. But even with millions of data points, machines can still make mistakes. So that's a fascinating thing. We don't need millions of data points, and we're able to learn and adapt, but machines might get millions of data points and still make mistakes. So somewhere in the architecture or somewhere in the way a machine is learning, things are not enough, right? So that really helps you appreciate your own brain. Your brain is so, like, if you think you're not smart, think again. You are really smart to be able to just do daily activities, just to hear me speak and understand what I'm saying. You're really smart. Okay, so that's a little bit of philosophy of machine learning, right? Okay, when do you stop learning? For humans, learning doesn't stop, right? This is again more in the philosophical dimension. Like we have very complex learning spaces. You learn like you're here to learn about computer vision, so that's technical. Then you say, oh well, I go back to my life, and then I have relationship learning to do. I have to learn how to grow in relationships. So that's a whole another dimension. So for us, learning is multidimensional and it doesn't stop. For machines, you would say learning stops at some point, and you can also check if learning has stopped. So this is, the graph that we had earlier. Where is that? Here. Yeah, this is an example of that. Oops. Yeah, this is an example of how learning could stop. You're feeding it more and more data, but you're not improving the learning. And how do you measure learning? Well, in machine learning, we have some metrics like loss function, what's the loss value, what's the precision recall, or what are metrics that you care about in machine learning? It's not improving. You're feeding more data, you're doing these iterations, passes through data, and it's not helping. So you say, I stop. I'm not improving. So there are ways to measure if you're improving or you're not learning as much for machines, right? And yeah, we also covered what exactly is learning in machine learning. It's learning the patterns in the data. It's learning to make predictions. It's learning to. It's also sometimes learning can mean understanding things better. So in natural language processing, for example, we talk about semantic understanding. So semantic understanding is saying, I understand what you're saying so that I can respond to you, right? So that's very different from just putting a class to something. Like you said, can I have a glass of water? You say, oh, you're asking for water and you want a glass of water. Okay, then I'll say, okay, here's a glass of water. So if I didn't do that, if it was more simple, I would say, oh, you said water. Okay, I understand water, but that's it. You don't understand that you want a glass of water, which is very different from just saying water. So learning, it can mean different things in different contexts. And essentially, it is enough understanding that you can make predictions. It's enough understanding that you can make smart decisions. So that is what learning in a machine learning context means. And mathematically, it's more like you learn some parameters or weight vectors that can help you make these predictions as accurately as possible. Okay. Another philosophical thing, what's the difference between machine learning and AI, right? So, this is, I've kind of referenced one take on this. You can take a look. AI is more high level. It's like all that fancy stuff. People say, oh, AI is this, transformers, AI is all the things that you see in the movies, or AI is robots, So AI is like kind of the front end of what machine learning can do. It's the things that excites you. It's like, oh, how did you generate that video from just a sentence? Or how do you generate that image from that text? So that seems like AI. So it is things that enable computers to mimic human intelligence. So that's one way of defining AI. So, the classical definition of AI is, can you, there's that Turing test, right? When you have a conversation, you're not able to differentiate if it was an AI speaking or a human speaking. So if you pass that test, you pass a Turing test. So that was a classic definition that Alan Turing shared on AI. So trying to mimic, and human intelligence is like we saw, we are very intelligent, and we want to mimic it and automate it so that anything that can help do that, or applications where you do that, is AI. But how do you actually do it? You need to do machine learning. Without machine learning, you don't have the tools, you don't have the methods to actually do AI. Then it's more of a buzzword. So, do you do AI? Yeah, I do AI. I like AI. I like talking about AI. Talking about AI is different from actually working in AI, right? And implementing AI. So that implementation happens through machine learning. And deep learning is a subset of machine learning that is that can do some really high-end tasks and have really high performance if you have enough data. And specifically in applications like computer vision and NLP, deep learning is like a staple diet, right? So these are like, it's very well established that you have to do deep learning for getting good performance in natural language, also speech. So speech processing, computer vision, and NLP, right? But then there are other things like anomaly detection and clustering, where standard machine learning techniques are good enough. So this is kind of a breakdown of that. Okay. So a few things before we wrap up for today. So your assignment 1 will be due sometime end of next week. But we'll also assign it sometime end of this week. So you have some time to work on it. And it's going to be based on image processing, basic image processing techniques. We'll cover those in the next lecture, next 2 lectures. So Python is the main language we'll use. And you can prototype in notebooks, and you can submit the notebook as such for smaller assignments. For mini projects and Kaggle assignments, we will ask you to keep your code more modular and organized, like use some classes or things like that, so as to organize your code like you would actually write code in an interview or in an industry setting, right? And you can use Google Colab, highly recommended, because it has a lot of good features, especially when we get to deep learning as well. You can leverage some of the GPU instances that they provide to do deep learning using PyTorch with GPU instances. So feel free to set up your Google Colab for your first assignment as well, so that you can start working on it going forward. Okay. Yeah, a couple of things on just maximizing your learning in this course. Feel free to ask questions, right? And clarify things as they happen. Like you might think, oh, I have this question, but I don't know if it's relevant or if it's, intelligent or anything like that. Just, I'm very sure someone else might have the same question. So just ask it anyway, and, we can clarify it and we can keep moving on. Make use of the office hours and quiz section that we have. So we'll discuss this. We have a couple of office hours and quiz section for this course. And use Discord. So if you're not already on Discord, get yourself set up. It's a great place to brainstorm concepts outside class and unblock yourself, share ideas, share resources, share materials, share thoughts. So you can collaborate and brainstorm. And even for the assignments, you want to discuss some parts of the assignment, like not handing out the solution like, hey, here's a solution, but more of like, let's think about what methods might apply here, and you want to share some thoughts or get someone, want to pick someone's brain, just share that on Collab, right? Make it collaborative. Not Collab, sorry, Discord. Like I said earlier, 30% of your learning happens in this class and office hours. 70% happens when you work on assignments. So we will be placing a lot of emphasis on assignments. And this goes without saying, what you put in is what you get out. So if you want to maximize your learning, I would say bring in your excitement, ask questions in class, do your assignments, and work a little bit smart. Like, it's not hard work. I would say it's more of smart work. Optimizing your time so that, like, okay, I can struggle on some problem on my own for 4 hours, or I can just post on Discord. So that's a smart thing to do. So not waiting to figure everything out yourself, because sometimes it's easier to collaborate. Or, just if you're working on a Kaggle contest, breaking things down and, working on the critical pieces before you work on the other pieces. So that's, again, a smart way of doing things. So if you can organize your, work schedule, you can get a lot of things done in a little bit of time, little less time. So then you'll get a lot out of this course. We've found in previous courses that we have taught, people have found the things that we've discussed in class actually being asked in interviews. And they were like, oh, we discussed that in class and we actually got that as an interview question. And thank you, and I got a job. So we'll be, that's why I'm saying just stay active and you'll get a lot out of this class. Okay. Office hours, I think we did a survey on this. I'm just posting some of the main times that work. And maybe Ayush, you can also clarify what works for you for office hours or quiz section. So lecture 1, sorry, this is off. The first lecture every week is on Tuesday. It's in person and it's 4 to 6. The second lecture, like today is like a second lecture, is on Thursday, 4 to 6. I'll be on Zoom. So my office hours, based on the survey, Tuesday seems to work best for most people. So we'll have it 6 to 7 p.m. right after class. And so we'll be in person, right? So I'll be in person so we can discuss it, at the building. So we'll be mostly in one of the EC buildings, EC rooms. I tentatively put Wednesday and Monday for office hours of Ayush. I think we'll also have grading hours. I'll let Fatwir talk about this sometime today or maybe the next lecture, just to discuss any questions you might have on grading. So you can go to the grading hours. This might happen once every 2 weeks, so you can get your grading questions resolved. So Ayush, if you're around, can you jump in on these 2 dates?
Yes, sure, Karthik. Actually, I will just have a look at my own schedule and then let everyone know through Discord the final office hour and quiz section timings.
Okay, sounds great. So this is kind of the rough thing. So you have all of these resources, lectures, officers. Okay, also wanted to mention, I'll share a Calendly link where you can pick a 15-minute slot in October or maybe even November, just to have any one-on-one discussion that you may want to have on computer vision or anything else. Also as a way to touch base and clarify any things. You have that option. You can pick that Calendly slot and just we can discuss anything there. But that's also available if you want to, because office hours will have many people. If you want to discuss something in person, then you can pick a Calendly slot. Okay, so these are the resources, plus Discord. So you have all of these resources to help you get the most out of this course. And in the next lecture, we'll be looking at building blocks of computer vision, image processing, image smoothing, some basic image transformations, refreshing our convolution, understanding of convolutions and things like that. Simple image features for learning. And I think basic machine learning for computer vision. Maybe this will be next lecture or this will be the third lecture. So we'll see, depending on how we go through the material. Yeah, so I think we're done. Any questions, feel free to ask, but we're done for today. Recommended resources, yeah. So we will share some recommended resources for computer vision. So some pointers and some references and lectures. I haven't yet picked any textbook that we'll be following as of now, but if there are some interesting materials that I'll be closely following, I will be sure to mention it as we go through the next set of lectures.